All right, one of the final pieces of the puzzle is to allow a player to choose that they're happy with their hand and they want to finish. So we're going to need to add another button, but we don't want that button to be something that is there in every game. This is specific to here. So I think what we're going to do is make in our game provider, um, we're going to um, create something and it'll be a list of widgets. List of widget, and it will be, we'll call it like additional buttons. And it's by default just going to be something like this. So that's all good. Now, what we want to do is in our game UI, wherever we have that new, not new game, but is it end turn? End turn. We're going to, in this row, we're going to want to add those buttons. So let's see, that's the column, this is the row. So what we could do is we can then, we can do a spread. There's a few ways we could do this, but we can do a spread operator here and actually go in additional buttons. Now this has to be model.additional buttons. And let's just see, first of all, what that does for our game. And we had an error because I didn't save both, but no problems there. Now, this might not be the best way to do this because we're not really in a widget tree. I'm curious though if it will work. And we might actually have to, and in fact, yeah, instead of a list of widgets, we're going to actually create something. And I'm going to do it here for now, but we might move this around. And it's going to not be it's going to be a class called we'll call it like an action button. And it's going to have a label, which is a string. So final string label and final function. And it just be a final function with no parameters called on pressed, we'll call it. And then we want to make sure that when this is constructed, we are requiring this dot label and requiring this dot on pressed. And I got rid of my lovely stuff there. We forgot a semicolon, and then we're good. So rather than actually having a widget here, let's return a list of action buttons, which means this is now going to not work because we're no longer widgets, but we can then map over these and make sure we convert it to a list after. And we'll call this button. We want to actually return a button that has we'll just use that same thing, an elevated button on press. We won't do, or on press will be whatever that button dot on pressed is, and its child will be a text with whatever the label is, right? So this will allow us to kind of have, aside from our standard button, we can have multiple buttons here. So we do that, and we have to save this. And we get this little issue here, and I think that's just because we made some change and I didn't save both files at the same time. But let's find out. Okay, great. So if we did go into our additional buttons now, just to test, let's make this a little bit different. Let's put in a action button, and its label is going to be test, and its function is going to be, we'll just kind of like print hi. And we will save that. And I'm just going to make it a little bit cleaner. So now we have additional buttons. Now we will refresh to hopefully be able to see this. And there we go. We got the test. We got the end turn. I'm also going to wrap any of these buttons in a padding. Wrap with padding, but we're just going to do only right of maybe like 6, just so that they get spaced out a little bit. 3 maybe. We'll call it 4. Awesome. So now we have these ways to have these buttons. Now I'm thinking in my head, we could probably actually refactor this so that even the end turn button is part of that, but I'm not going to worry about that because the end turn button is, going to be required in most games. So we'll just keep it kind of fixed, but this allows us in any game to actually have some additional buttons. So we will have a list of additional buttons right there. And the cool thing is we can override that in our 31 game provider. So override, I don't know why, additional buttons. And here we actually want to return an array, or list rather, of these things. And we're going to put a action button, and its label will be, I'll just call it knock. And on pressed will do something, but we'll get there in a bit. Okay, so at least now we have the option to sort of have this additional UI, and we will put it here. One more thing we should probably be keeping track of is, and we might have to refactor something for this, but let's do a final Boolean disabled, or actually we'll use enabled, and we'll do this dot enabled, and by default it'll be true. Okay, and that's fine. And then in our UI, discard pile, or game board rather, we can then pass over, I think there's a, oh yeah, on pressed. So on pressed, in order to enable or disable something, we can go button dot enabled, and that'll be the function that gets called, otherwise null. Okay, so we should see after I finish my turn, just to make sure this is working, which I will do, I can end my turn. Okay, so that button is still showing up. So we do need, right, because we have this here. This, I'm thinking like, yeah, we shouldn't ever show, we should not ever show these when, I'm thinking we can probably just move this up to the row itself, and kind of just change this. So what was it? Let me just undo. So what I can do is I can grab this guy, erase this, and put this at the row, and then do a question mark. And then at the end of the row, we can just do a container. So now if I end my turn, which I will do by just playing this, and end turn, there we go. Okay, so we have a knock, it goes away, and when it's my turn again, it shows back up. Okay, so let's figure out our knock functionality. I think with this, we can make use of our game state. So we have this button, and we're going to just do, we can go game state, and we can say, oh, hi Siri. Game state, we can, and let's go to our constants, and we'll make another one, const player has knocked. Remember, this is just a way that we can kind of have some keys on this generic stuff. And in fact, this shouldn't even be a constant necessarily in our main constants, because it really is just going to be specific to this game. So I'm going to put it here. Player has knocked, and we are calling it. We start them with GS just so we know what they are, and we'll just call it GS. I'm just going to make it the same thing. And this is just so if we're accessing this in multiple places, we will be less likely to make a typo, because working with strings is very easy to have a typo. And let's just try something here. I should be able to just go, like this could just be like set it to true or something like that. But I am going to try at least to use the current player. So turn dot current player. So we're actually going to track who is the one that knocked in theory. And then, yeah, so that's all good. If I click knock, I don't get any errors at least. So then what we want to do is, well, we want to set, that's one thing we want to do. We also then want to end the turn. So I think we can just go end turn, and let's just remember what that does. Because when you knock, you're also ending turn. Turn on next turn, bot will play if they can, etc., etc. So we'll just, let's see. So if I click knock, it does end my turn. This one plays. Now what we need to do is kind of have a way that, okay, at the game is over. Yeah, I think we can actually handle this in the game is over function, because when we can go if game state, and then we can use the game state player has knocked, does not equal null, and game state player is knocked. Actually, I think there's a, we'll just try it this way first, is equal to turn dot current player. And I'm just going to do something like print end, and we will return true. Otherwise, we will return false. Okay, so now this time if I click knock, it goes back, he still plays, and then game over. So we are pretty much there. So what we need to do now is we have a in our game provider, game is over. Oops, let's find where that is. Yeah, so we have something called finish game. So we can override that too. Let's just see what that actually looks like. And I'm just going to copy it over. And we need to make sure we copy this override as well. And this is where we would do our logic to count. So what we can do, and we'll make this simple at first, and then we have to make it a bit more complicated because of the way the rules work. So what we can do is for final p in turn dot players, or we can actually use players. They're going to be the same. For plea in players, we're going to do some stuff, and then we're going to make a variable. It'll be a integer called points. It's going to start with 0. Then we want to go for C in p dot cards, and for final C in p dot cards. Essentially, we want to count and give them a score. So there's probably a cleaner way to do this, but what we can do is, first of all, we have on a card a value. Now the value isn't an integer, it is a string. But what we can do is we can do a switch on C dot value. And we'll go case, and we'll do king, case queen, case jack. And in this case, if it's any of those, we're going to go points plus equals 10. That's how many points that person gets for each of those. Then we have a case for ace, and we have to break. Otherwise it will try and keep running through this. Points plus equals 11. Okay, then otherwise, so if none of those are true, we can run our default case here. Oh, we also need to break. And we can take whatever that value is. So you can go points plus equals C dot value. Now this won't work because this is a string. So now we have to actually parse it as an integer. This isn't the safest thing to do because who knows, maybe our API changes something. But for now, we should be good. We don't need a break after the default, so we're fine. So after we get through all their cards, we can then go and let's actually update our player model, just so we can keep track of this. And it's not going to be final. It's going to be something called points, or let's call it score. Int score, and we can go this dot score. And it's going to equal to 0 when it goes. So we could, start the game with a higher score by passing it in, but otherwise it'll default to 0. Meaning now we should be able to go p after we've looped through all the cards, which is here. We can go p dot, and in fact, actually, why don't we do it this way? We should be able to just go p dot score instead of like kind of tracking it in a temporary variable. And then let's just go to the very end of this, and let's just do a print. And we'll do player, we'll do, actually, let's do this. We'll do this part in the loop just for debugging purposes. So within the player's loop, at the very end of counting their cards, we will print p.name. What did I do wrong? I forgot that. p.name, and then we'll do p.score. So let's just see how this behaves. And I'll need to save that file too. And we'll refresh. And I am just going to knock right now just to get through this. And there we go. Tyler had 21, Bot had 22. And if you add these up, yep, that seems to check out my mind. Now, this isn't quite how the game works. It's not just what points you have, it's the points of each. You have to pick whatever suit is the most. So we are actually going to have to kind of go back to a slightly, we have to do this just a bit differently. So what I'm going to do is before we actually loop through the cards, let's just set a point for each suit. So we're going to make a int called points diamonds, or let's just call it diamond points. It's going to be equal to 0, and we're going to duplicate that three times. Spade points, club points, and heart points. Let's pluralize them. It sounds weird to say it that way. Okay, so now what we actually have to do is we will then make that variable we're talking about in int, and we'll just call it points, and it's gonna be equal to 0, and we're gonna actually go do points. So we're gonna add that variable. Then that's just in the switch case. So then at the end of the switch, but before we loop to the next one, we'll do another switch. So this is going to look a little bit messy. There might be a better way, but you'll get it when it's there. C.suit, and let's just do case suit dot clubs, sure. And so if the suit is clubs, we want to then take the spade, the clubs points plus equals points, right? Case suit dot diamonds, and we forgot our break. Diamonds points plus equals points. Case suit dot hearts, heart points plus equals points. And yes, we do need to put some breaks in. We'll get there. I'm on a roll. Suit dot, what do we have? Clubs, diamonds, hearts, spades. Spade points plus equals points. And then we'll do default, and we're just gonna not do anything in there. Can I pass? No. Okay, break. Okay, then now that we have that, so we've looped through all these, and we want to make sure that in this part here, so after we loop through all the cards and essentially incremented them, we want to find out which one's the most. So I'm going to, just to see if this even works, let's just kind of like do spade. Oh, I don't know what's happening. Spade points. Is this not in the, where's the loop that we're in cards, in players? Am I in the wrong spot? No, I'm here. I just spelled it wrong. Spades, hearts points, diamonds points, and clubs points. Spades, hearts. Let's just see if this logic actually works before we figure out how to assign it. And okay, refresh game. And new game, knock. Just knock it right away. And okay, so we see now this is for happening for both players. So 0, 16, 0, 8. That's probably me. Yeah, 8 for the clubs, 16 for hearts, 0 for the other one. So that is working. What we need to do is find out what the max is. Now, we're not just going to be like adding these together because you only get the one for the most. So we're actually going to make a list of all these things. Spade points, heart points, diamond points, and club points. So we just kind of have a list of all these. And then we can do what's called a fold. So fold's a way that you can, and I sort of have the stuff up here. And we take the initial value is going to be spade points. Oh, wait. And then I think we just pass in the word. Where does max come from? The Dart math library. Yeah, we have to import from math. And we can just pass in the function. So this should print total points. What happened here? Oh, I put this in the wrong spot. So we should be able to just go p dot score is equal to total points. And then let's just see if that works. I'm going to get rid of these guys. Print total points. And let's just make sure we're good. I'm going to restart. New game. And this, if I knock now, and in fact, yeah, no, this is perfect. This is perfect. So let's knock. Bot goes, and it's telling me one of us has 17 and one of us has 15. Now 8 plus 7 is 17, and yeah, spades 15. So there you go. There's your logic to determine who the winner is. Now, a little bit of tidy up here we'd have to do. We obviously want to like actually end the game, and set these points and do like hey, this person's the winner. But we basically have the logic here. We could play for a long time and I could try and get 31. Let's see. So I'm not gonna pick that up. I'm gonna go blind and I'm gonna discard. I have a lot of clubs now, so let's discard that and I'll end my turn. Let's see how close we can get. That card, it's slightly helpful. Let's grab it and end turn. 7. I'm getting a lot of clubs, but nothing that much better. End turn, and let's just. So I can see they have the queen of clubs. They don't have any strategy, so I'm not worried. I might get that. So let's just kind of go through this quickly. Oh yeah, the order. Eventually, I will get that queen of clubs, knowing that the bot has some really good rolls. So we'll very quickly, just finish this up. End turn, and I should get the queen of clubs now. So I'll grab that, and I'll get rid of my 8. End turn. And I'm gonna call this and say knock. And we'll see here, I got 30 points, almost the max 31 and everything. So yeah, that's kind of it. Like have fun, make your own games. I hope you learned a lot about just making a Flutter app.